Foundation. Siyathemba nizolijabulela lolu hlelo.
Grade 12 physical sciences namhlanje so it's a revision paper 1 but as to paper 1 unama learning area out 3 that is mechanics, wave, sound and light, and electricity and magnetism. Kube khona a topic on matter and material, that is a photoelectric effect. Right, so paper masilibuka as paper 1 kumele sibe aware ukuthi inezophuma so that masiya kuyobhala leyo exam sibe aware ukuthi sibe prepared accordingly. So njengoba ngisho ukuthi i-mechanics, masikhuluma nge-mechanics ka-paper 1 inama Newton's laws, kunama Newton's laws la kuhambisana nama forces and motion of the object in a vertical projectile motion. Vertical projectile motion mese iba ne momentum and impulse. Momentum and impulse mese kuba work energy and power. Work energy and power. So now I'm a topic I fall under mechanics. Right. So besikhuluma ngalokho, but we still know ukuthi khona section yesibili ethi wave, sound and light. Wave, sound and light, but wave, sound and light idila nani ne Doppler effect. Doppler effect. Then the last one is electricity and magnetism. Electricity and magnetism. The part ihamba nani ne electrostatics, kona electric circuit, bese kuba electrodynamics. So those are the topics to expect ku paper 1, right? Nangizoqala nge-mechanics ngoba iyona vele i-part izofika qala kwi-paper lakho. Question 2 ngoba question 1 vele kwi-multiple choice. So question 2 uzoba ama Newton's laws. Question 3 uzoba i-vertical projectile motion. Question 4 momentum and impulse. Mese kuba question 5 uzoba i-work energy and power. Kahle kulandelana ngaleyo ndlela ke kwi-final exam. Right, so zama cover almost wonke ama topic, but the main thing masikhuluma nge-mechanics still anama forces and then sibuka emotion of the object. Right, so those are the key points: the force and the motion. The force and the motion. Kumele siyazi in terms of the motion of the object. The first thing masithi khuluma nge-motion of the object, asikhuluma nge-state. Right, a state of motion. Right, state of motion. I think kwa manje sikhuluma ngama state out 2, right? In terms of state of motion, we'll say that the object is either stationary. The object is stationary, normal. The object is moving. Right, an object can be stationary, normal. It can be moving. Magu stationary, what does it mean? Magu moving, what does it mean? In terms of ama quantities, kumale siwafake masenza ama calculations. So the moving object sinendlela ziwu-2. The object ingaba moving with a constant speed or constant velocity. That is the first situation. Esibili ngaba ukuthi ihambe nge-constant acceleration. Constant acceleration. Right. So makuthiwa a stationary object, or amanye amagama asho the same thing, ati the object is at rest or an object is dropped. So you know what the velocity noma initial velocity of the object is over 0. So sotini velocity of the object is 0. Now mawuthi velocity is 0 angithi lokhu hambisana nemotion asibukeke in terms of forces. Now sizohlezi sihlanganisa wonke lama force ngoba sikwazi ukuthi sihlukanise which force is this, gravitational force noma subeke konke nje all together bese siyakhuluma nge net force. Kusho ukuthi ngala njengoba i-object is stationary kusho ukuthi i-net force is 0. Makuthi net force is 0 ne-acceleration izoba u-0 na, right? Then asibukeke makukhuluma nge constant velocity. This time the object is moving kodwa ihamba nge constant velocity. Kumele uqaphele njalo makune statement makuthiwa constant velocity, what does it imply? Makuthiwa constant velocity. So ukuthi lana i-velocity vele it's not 0 ngoba i-object is moving in a velocity, so velocity is not 0, but the net force will be 0, right? So net force is 0 in two situations: when the object is stationary and when the object is moving at constant velocity, right? Makuthi net force is 0 kusho ukuthi ne-acceleration nayo izoba u-0 ngoba siyazi ukuthi acceleration is the rate of change of velocity. So there is no change in velocity ngoba kuthiwa constant velocity. Kusho ukuthi initial velocity iyalingana ne-final velocity. So that gives you what? A 0, right? So that's it. The difference between stationary and moving at constant velocity is over velocity kupela. The initial one, velocity is 0. Ngala constant velocity, the velocity is not 0. Kodwa net force is 0 and acceleration is 0 for both cases. Right, mese kubake a constant acceleration. The object is now accelerating. So in that case, if velocity is not 0, that's the first one. The other thing, njengoba kuna constant acceleration, kusho ukuthi kuna initial velocity and kuna final velocity. Kuna initial velocity, kuna final velocity. Kungenzeka ukuthi initial velocity abe u-0, kodwa final velocity ngabe u-0, noma final velocity abe 0 and initial velocity not 0. As long as you have a change, then we'll talk about the acceleration. Acceleration is also not equal to 0. The net force as well is not equal to 0, right? So that's it. But uyakumbula ukuthi masikhuluma ngo net force singakwazi ukuthi ile net force ifake ku work done. Ngoba ma calculator in net work done, uyakumbula ukuthi net work done we calculator as the net force times the distance or the displacement times cos theta. So we are going to the net work done will also be 0 if the object is moving at constant velocity. So we are going to constant velocity can take you from Newton's laws, work energy and power as a topic. So everything is related. Is mechanics. Right, now what is the next thing we need to look at? Ngoba sesikhuluma equations of motion ku VPM, masikhuluma nge force, masikhuluma nge motion of the object, masikhuluma nge Newton's laws. Now we have 3 laws of motion. So khuluma ngama Newton's laws of motion. Newton's laws of motion. So you have the first law. The first law is an object will remain in its position of rest or constant velocity unless there is an unbalanced net force acting on it. So kusho ukuthi ngeke i-object inyakaze from rest unless khona force ezoyisusa lapho. Now if the object is from rest, then you move it, uzobona ukuthi say in a velocity. So initial velocity was 0, then it's moving with another velocity. So there is a change in velocity. Ngakho sothi kune change in velocity. Mase kune change in velocity, siyakwazi ucalculate in acceleration. Then you have the second law as well, right? The second law, it talks about acceleration ngoba seku-apply i-force that is not equal to 0. About first law no second law kahle kuyangenelana ukuthi ku-first law ukuthi wena the object makuthi ihamba nge-constant velocity noma i-stationary izosala kuleyo state unless uzo-apply abani i-net force engekho equal to 0. That is Newton first law. Then what if sifaka a force that is not equal to 0? Sekuzuyisa kepi ku Newton second law. Uzoti when a net force is exerted on the object, kahle sikhuluma nge non-zero net force is exerted on the object, then the object will accelerate in the direction of that net force. Then so tologuti leo acceleration leo is directly proportional to the net force. Kushokuti when you have a greater net force, the acceleration now is obenkulu and inversely proportional to the mass of the object, right? So this is Newton second law. Uma ukuluma nge net force and the mass as well. Kodwa ke uyakwazi futhi ukustate in Newton's second law in terms of momentum. Yona izoti the net force acting on an object is equal to the rate of change of momentum. Right now, this one is still the Newton second law. Kodwa ke it is in terms of momentum. Right, acceleration directly proportional to the net force and inversely proportional to the mass. Normally, the net force is equal to the rate of change of momentum. That's still Newton's second law that we express in terms of momentum. Mese kuba no third law, Newton's third law. Newton's third law odila ne action reaction force. If object A exerts a force on object B, then object B will exert an equal force to object A, but in opposite direction. I-application ya Newton's third law ile umona ukuthi mhlambe kunama box awu-2. There is this first box, mhlambe zothi box A and then box B that touch each other. Mhlambe kune friction lana between the surface and box A and also between the surface and box B. Bese kuba khona i-force epusha u-A. Siyabona ukuthi makune force epusha u-A kusho ukuthi no B uzohamba. But in terms of forces, masidweba i-free body diagram ku-A, siyabona ukuthi u-A une mass, so khonani kune gravitational force. Beside that, this box here ilele ke kwi surface, so in a normal, then kone friction ngoba kuthiwa a rough surface, we have a frictional force acting on that object. But besides, siyabona ukuthi kune force applied F. Ma representa a free body diagram, kumele njalo ama forces akho avele as ama pulling forces. Angithi ngala umona ukuthi i-force ipusha u-A, kodwa ma udwebe free body diagram, you draw the force as a pulling force. Mangithi a pulling force wena udila ngani ne direction kuphela. This force here is acting is making the object to move to the right. So isusa ngala and then take it to the right. That becomes what? The applied force. Kubanjalo, right, as the applied force. Doesn't matter, it doesn't change anything. Maguti le force about 20 newtons. Nala apply the pulling force of 20 newtons, same effect. Go more calculate the acceleration, uzoti A is equal to net force over the mass. So guti force, it's a pushing or a pulling force, it doesn't matter, because if the force is still the same magnitude and the same direction, will have the same effect. So inga kongtiwa, when you represent a free body diagram, always make sure you represent it as ama pulling forces. All the forces should be represented as ama pulling forces. That into just know the direction, right? The magnitude and direction, that's all. Then A uzobona ukuthi this force here is making the object to move to the right. So you take A as the point of application and pull it to the right with that force. Right. Mese-ke sibona ukuthi if there was no B, lo A bozohamba njengokushesha. Manje njengoba kuno B lana, u-B represent i-resistance, right? It opposes to that motion. Kusho ukuthi u-B exerta i-force on A, ngoba u-B uzohamba ngenxa yokuthi u-A uyamphusha on the right side. Kusho ukuthi u-A exert a force on B, but at the same time u-B ngathi uyamresista ukuthi u-A angasahambi on the right side. Kusho ukuthi u-B is also exerting a force on A. So beside the forces awu-4, there is also a force that B exert on A. So TFB on A. Right, that is the fifth force. So kuna force awu-5 a-acta u-A. There's a frictional force, gravitational force, the normal, the applied force, and the force that B exert on A. Masibuka ke i-box B. The box B nayo in a gravitational force, that is the weight of the object in a normal, then in a friction, then a force that A exert on B. It's also a pushing force. Kodwa njengoba ngishilo, we don't represent ama pushing force, we represent them as a pulling force. Now sine force ezoti F of A on B. Right, into fanesiyazi yokuthi le force le euthi F A B to A is equal to the force that is A on B. Right, the force that A exert on B iyalingana the force that B exert on A. That is the application of Newton's third law. Right. Then beside the three laws of motion, the law of universal gravitation. The law of universal gravitation. Right, the law of universal gravitation states that the gravitational force, this force here is a gravitational force. The two objects in the universe exert on each other will be directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. Kala kumele sibe specific, kumele uthi between their centers, ngoba i-gravitational force acts at the center of the object, the center of gravity. Right. Now, mama uyibuka ngale ndlela uzobona ukuthi if it is on the planet Earth, for example, G it's a constant, a gravitational constant. Now, mass of the Earth, if we are using a mass of the Earth and the radius of the Earth, makuhlanganisa goku kukiphela bani i-value ethi 9,9,8. So G wethu sumcalculator ngokuthi sebenza G gravitational constant, the mass of the Earth over the radius of the Earth, so the r squared. Right, now loku on Earth ukiphela bani i-value ethi 9,8 meters per second squared. So 9,8 vele uqhamuka la ukuthi the radius of the Earth uyayazi, and then you have a constant, and the mass of the Earth is also a constant. So tola 9,9,8. But the gravitational acceleration is not always 9,8, because let's say konentaba ngala mhlambe no 600 meters high, right? And konomuntu omengala and omunye omphezulu. So bona ukuthi the gravitational acceleration on this person is not the same as this one. Ngoba masikhuluma nge-radius, let's say this is the planet from the center of the Earth to the surface. That is the radius esiyisebenzisayo. But if then there is something like this, about a height it is, then we need to add that distance. So this will be the radius, message ya add distance. So it can make a difference in terms of the force that the Earth is exerting on another object around it. So lo 9,8 somsebenzisa just right? Ngoba asikwazi ucalculate every time, so we'll assume that the average radius of the earth will be the value that is given. Now lama values le awudingi wa memorize ngoba uyanikezwa wona from data sheet. So that's it for ama Newton's laws. Then the application, most of the application, it's about Newton's laws, but the main thing kumele ukhumbule ukuthi ama forces kumele ube ready kuwa calculator, njengoba sasho ukuthi khona gravitational force, kune normal ucalculate kanjani normal, kune friction ucalculate kanjani friction, kune tension ucalculate kanjani tension, kune applied force. But beside ukwazi ucalculator kumele wazi ama definitions. What is the weight of the object? What is the normal? What is friction? We know ukuthi sinama friction awu-2, kone static friction and kubene kinetic friction, right? Meso calculator would define a futhi the tension, and you have a applied force. So every time mama une sibalo esikhuluma ngama Newton's laws, just let's say sine example, and there is a force exerted there at an angle of 10 degrees. The force lambe to 60 newtons, right? Message soti the mass applied the lambe 8 kg ngala tibe lambe no 5 kilograms. Then there is a string that connects the first box to the second box, right? Message lambe kutiwa i force, frictional force ngala lambe u 0, let's say lambe 8 newtons, right? Ngala so lambe frictional force nayo uzoba 8 newtons, right? Umbuzo ngati ukuthi why kulana frictional force, let's say 8 kg nalo 5 kg, they are all having what they are having same properties, kusho ukuthi ama physical ama chemical properties of the two boxes are equal. Kota sibona ukuthi lo uno 8 newtons nalo uno 8 newtons, even though it has a greater mass and so on and so on. So into siyakwazi ukukhuluma ngayo ukuthi lo frictional force yakhe iya decrease simply because khona I applied force at an angle, Fy, right? The vertical component of this particular force, right? Mase kuthiwa ke let's calculate the force or the acceleration or normal as calculated tension between the two boxes. The main thing to do kumele uqale udwebe a free body diagram, right? So I'll start with the 5 kg block. 5 kg block ngazi ukuthi kune gravitational force, kune normal, bese kuba ne friction, bese kuba nani, kuba ne tension. Sekuphelile njalo. Ma udwebe free body diagram ubuka the box ofuna ukudweba I free body diagram. So mangifuna 5 kg, I ignore lo 8 kg ngibuka nje 5 kg kuphela. Then I'll know that I will never say ukuthi force is also exerted to that. Into ngibonayo around 5 kg, that is those will be the forces acting on it. Amanye ama force awutshelwa wona, but you know ukuthi they exist, such as a gravitational force and a normal force. So ama force awu 4 acta kubani ku 5 kg. Bese sibuka kulo 8 kg block. 8 kg block na une gravitational force, une normal force, siyabona ukuthi kune friction, and the friction opposes the motion. Then kune tension futhi. I tension uyibuka on the side. Yabona njengoba 8 kg intambo ibambe on the left side, kusho ukuthi ne tension idonsa nayo from to the left. Mese siba ne applied force. Siyabona ukuthi I applied force goes northeast, so we draw it as it is. So we have 1 2 3 4 5. Our 5 ama force actor kulo 8 kg block. Now, what should be the next thing? When akumeleke manje uthole ama force are parallel to the surface. Uthola ama force are parallel to the surface. Mangibuka lokho gravitational force ne normal they are perpendicular to the surface, so I ignore them. Ngisebenzisa lama force are parallel so that ngizothola tension, so that ngizothola i net force, a frictional force out. Now I ignore what the perpendicular forces. Ngize la ku 8 kg, ku 8 kg une friction, kune tension, mese kuba i-force, but ngiyabona ukuthi this force here it's acting at an angle. Ingakho kumele ngithole bani ama-component akhe, ngoba ama-component akhe azoba awu-2, one will be vertical, omunye uzoba horizontal. So kumele ngisebenzise le horizontal, so ngizothola bani u-Fx, akusiyona u-F. Yabona njengoba kuno 60 newtons, angisasebenzisa u-60 ngoba u-60 awukho parallel to the surface. Kumele ngithole i-component yale force e-acta parallel to the surface. Yona ngicalculate ngokuthi u-Fx ngizothatha u-F ngithi times cos of that angle. So in our case that will be u-60 times cos ka-10, ngoba sithe the angle here is 10 degrees. So mangisebenzisa i-calculator 60 times cos 10, so thola ukuthi it's a value closer to 60 though, times cos ka-10 kusigibela 59,09 59,09 newtons. Right, those are the forces. Masukwazile ukuthola ama forces are parallel to the surface, then uyakwazi ukuthola bani i-net force. The expression of net force is very important. So into efanele uyenzeke manje ukuthi ukhethe i-direction. So my advice in terms of i-direction, kuzomele wena ukuthi tata i-direction ihambisana nani ne-motion of the object. Mawubona ukuthi kule case unayo the object is moving to the right, kungaba right na ukuthi i-direction yakho ezoba positive ile ihambisana nani ne-motion. Mawubuke example yethu ukuthi if i-system is moving to the right, so take to the right as positive. Kusho ukuthi kulama force lawa afake on any force ekhomba to the right, that will be positive. If it goes to the left, that will be negative. Right, so sesingabhala ke ubani ngabhala net force, the equation of net force. So net force ngala sekusela ama force awu-2 kuphela, normal no gravity asabafaki ngoba they are perpendicular to the motion. So tension is about to positive ngoba it is to the right, then the friction is over negative because it's moving to the left. Mese sizalana ke ku 8 kg, still siyabona ukuthi 8 kg yena unama force awu-3, right? Then so the net force kulo 8 kg uzothatha Fx uzoba positive ngoba is to the left, to the right. Mese siba ne friction to the left uzoba negative, ne tension that will also be negative. Sungayenza ke ini i-substitution, sungayenza i-substitution kuma value unawo. But then beside that, masukwazi ukuthola i-expression of the net force, kumele ukhumbule ukuthi njengoba sebenzisa Newton second law ukuthi the net force is also m times a. Lokhu kuyasebenza for 5 kg kuphinde kusebenze noku 8 kg, also ma. But i-mass siyayazi ukuthi 5 kg, i-acceleration asiyazi, ne-tension asiyazi. Njengoba sikhuluma nge-net force, kusho ukuthi kunendlela eziwu-2 zokukhalculate u-net force. Siyamcalculate using the sum of the forces, noma simcalculate using the acceleration and the mass. So into soyenza ke manje si-equate laba u-2 ngoba bayafana, the same magnitude, the net force. So njengoba ngithe mina ukuthi T minus net force is T minus the friction, ngiphinde ngithi net force is m times a, kusho ukuthi T minus f friction iyalingana nobani no ma. So ngizothi T minus friction is equal to ma. Sengizalana ke ku 8 kg block. To the 8 kg block ngenza the same thing, uno Fx minus, so kuno Fx minus friction minus tension ngizothi is equal to ma as well. Mese ngenza ini ama substitution. Sithe tension asiyazi, i-friction ku 5 kg block sithe anu 8 newtons, the mass u5 10 times a. So nginama unknown awu-2, t no a. lokhu kunginika bani equation yokuqala ngizothi equation 1. Lana ngifuna ukwenza futhi i-substitution. Fx ngimcalculateile sithole bani u59.09 excuse. So sina 59.09 zothi minus frictional force kulo 8 kg block now 8 newtons minus tension asimazi, then MA the mass is 8 times A. Bele I number lazy I can work out zothi minus 8, so lokhu kunika 51. So you know 51.09 minus tension, that give me what? 8A, right? So equation here. Sengine equation yesibili. Kodwa ngibona ukuthi kule equation yokuqala nesibili ngine tension, intention vele iyalingana for both boxes. The acceleration is the same ngoba lama boxes awu2 they are connected with a string, right? So acceleration, you know, so I have two equations with two unknown. So kumele ngenze njani? Ngisolve, right? Now when you are solving, the easy thing to do when you are solving simultaneous equation, into kumele uyenze when I just add the equation yokuqala we add the equation yesibili. So mangithi uya add ngizothi the first equation iti t minus 8 on the left side. Mese ngiza ku equation yesibili nayo iti 51.09 minus t. Ngik-add lana ngizothi plus 51.09 then ngiti minus t. Bese ngiza on the right side of the equation. The first one, you know, 5a ngizothi plus yesibili, you know, mani no 8a. Right? That will be a simple way of solving. Yabona ukuthi kuno t la kuno minus t. So definitely uT no t kuzohamba sengisele nani u51 minus 8. So ngizothi futhi minus 8. So kuzongikhiphela bani u53.09 is equal to, you know, 5a no 8a. That gives me what? U13a. Sengiyakwazi ke ukusolve for a, you divide both sides by 13. Kunkipela bani acceleration of 3.31 meters per second squared. That's how you work it out. So the first thing, look for the free body diagram. Then we have a free body diagram of all the forces acting parallel to the surface. Then emva kwalokho ke sungathola ke expression ka net force, right? Uhlanganisa lama force are parallel to the surface. Then usebenzisa ke Newton's second law equation ethi F net is equal to ma. So uzokwazi u-equate u-ma wakho kulama force owa edile from each box, izokunika ama equation awu2 mase usolve i-simultaneous equation. Ngithe indlela elula ke u-add everything on the left side. Equation 1 thatha konke ku equation 1 uthi plus konke ku equation 2, like on the left side. Mase uthatha on the right side of each equation uyaba add ke futhi ngoba kuno 5a uno 8a, that gives you what? U13a. So una acceleration u 3.31. Masifuna ucalculate tension, sungasebenzisa noma ipi equation, ungasebenzisa leyo kuqala noma usebenzise lesibili kuyafana. I-tension izoba izokhiphela nje i-answer efanayo. So mangibela ku equation 1. Equation 1 ethi t minus 8 is equal to 5a. I-value ka a sengiyayazi ke, so kusho ukuthi ngizothi t is 5a plus 8. So into ngizoyenza ke ngenza i-substitution. It's 5 times u-a sengiyamazi u3.31 yithi plus 8. So ngiyakwazi ukuthola bani what is the tension. 5 times 3.31, right? Bese ngithi plus 8. So tension u24.55 newtons, right? So kunjalo ke noma ungasebenzisa the second equation usazothola vele answer efanayo nale answer yokuqala u24.55. Mhlambe kungahlukana ke ngama decimals nje amancane, but it will always be the same ngoba le ithi 51.09 minus t is equal to 8a, right? Same thing lokhu ngikakuyisa ngala. mase ngikisa ngala ngiyakwazi ukuthola bani i-tension. Right, now uma kuthi siyakwazi ukuthola i-tension, so thini u-T mase sisebenzisa that equation yesibili, so minus T is equal to 8A plus 51,09. Mase siyasusa ke lo minus, so kuzoba minus 8A then minus bani 51, lo zoba minus mase kuzoba plus 51,09. mangenza substitution negative 8 times 3,31 that acceleration plus 51,09. right, so like CT it's 51,09 minus then kuzoba 8 times 3,31, right, kuskipela bani 24,61. nathi value ke ngisho 24,61 newtons, very close to this one ngoba la siqalisa round off ke ingakho i-round offing ivele siyise kule value ecishe ebe different to this one, kodwa ke uyibuka ngaleyo ndlela. Now the next way of calculating ukuthi mhlambe unikezwa i-inclined surface, right, une inclined surface mase kuthiwa there is this block here, right, then the other block asperity uthi sino 5 kg again, sibe nabani nalo 8 kg, a friction kusawu 8 newtons, mhlambe lo uzo increase mhlambe sothi 10 newtons, then asifake force yethu ka 60 newtons, then layer angle asisebenzise la sithi sino 10 degrees, right. Now kuthiwa calculate the acceleration of the system, noma acceleration of the 5 kg block. Kuyafana makuthi 5 kg no 8 kg bane acceleration efanayo, noma kuthiwa calculate the tension, right. Into fanele uyenze again is to draw a free body diagram. So mangibuka lo 5 kg, right, the free body diagram izothi i-gravitational force, I draw it. The gravitational force yazi ukuthi it's always perpendicular. It means perpendicular to the horizontal, means always what, vertical and downward. Mese ngiyabuka moto be free body diagram ku incline, my advice ukuthi ufake some dotted line izokhombisa ukuthi nanti surface is represented by ama dotted line. So the dotted line will assist you ukuthi ungalenzi iphutha mawudweba i-normal. Angisi normal is perpendicular to the surface, nanti surface, so sidinga yini uline o perpendicular to this dotted line ambisana nani ne inclined surface yethu sona ngala sothi i-normal, right, that is the normal. Then sibuka ukuthi khona friction, kusho ukuthi i-friction ishona ngala opposite ngoba from what we see this object or the whole system is moving up the incline. Then the next thing esibonayo ukuthi khona ne-tension, i-tension yona ayibona nje from ukuthi khona intambo nje ejoyina lo 5 na lo 8, so you have the tension. Those are the 4 forces acting on the 5 kg block. Mese ngibuka ke the 8 kg block, right, the 8 kg block nayo same thing. I'll draw a free body diagram. It has a gravitational force that yona it's always vertical and downward. Again ngite asifake dotted line to show the surface normal nayo izoshona ngala to be perpendicular to the dotted line that represent a surface. Then siyabona ukuthi khona ne friction, but beside friction khona ne tension futhi, so sinani sine tension mase kuba i-applied force eshona ngala, right, then you have the applied force, right. Now sidinga ke kudweba ini i-free body diagram that will represent our forces are parallel to the surface, Now makuthi parallel to the surface, we look at the 5 kg block. If the first force is parallel to the surface, sina leo tension, sinani sina friction. but then kune gravity here. Siyazi ukuthi ma kune inclined surface, gravity inama component awu-2, FG parallel no FG perpendicular. So at this case sisebenzisa bani FG parallel. Every time ma kune inclined surface FG parallel uhlezi ukhona uzomfaka kuma calculation. So sino FG parallel. So these are the three forces acting kule object that are parallel to the surface. Mangibuyela ngala ku 8 kg block, so nakhona ngizobona ukuthi nginale force applied, then there were two parallel tension ne friction, but then khona ne FG parallel. So those are the four forces acting on this object, right? So the process will be the same one as in the first example, right? So mangifuna net force, the expression of net force kumele ngenze njani, ngikhethe futhi direction. So njengoba ngishilo, it's safe ukhethe direction positive ehambisana nani direction of motion. In our case uyabona ukuthi the system is accelerating up the incline. So when uzothatha ukuthi any force going upward will be positive. So in that case ngizothini, F the net force. So ngibona tension is up there, mase kuba minus friction minus FG parallel. Mangiza kulo 8 kg block, same thing, net force wakhona will be the applied force, that is 60 newtons, ngizoti minus tension minus friction minus FG parallel, right? And usakhumbula ke futhi that F net is equal to MA. Nala the net force is also equal to MA, right? Mese wenza any ama substitution, then uzosolve futhi simultaneous equation. So Newton's laws are just like that, right? Now in a situation nje ifale sibuke mawukuthi hlambe there is a change in direction, right? There is a change in direction. Let's say kune pulley la, right? Then across this pulley there is a string joining two boxes. Lo hlambe una 16 kg, lo munye una 10 kg, right? The two blocks are connected by a string, right, over a pulley. Lo una 16 kg, lo una 10 kg. So into so understand ukuthi in this case gravitational force uzomfaka is in totality ngoba it is acting parallel to the motion of the object. So simona ukuthi i-acceleration izohamba ngala, but sidinga uyithola leyo acceleration. What is the acceleration of the system if we release these two? Now into fanele siyenze siyabuka futhi i-free body diagram. Mangiqala kulo 10 kg block ngiyabona ukuthi kuna ma force awu-2, right? I-gravitational force panti as a gravitational force, mese ngibona ukuthi akho normal ngoba the only time sikhuluma nge-normal makune surface. Angithi definition normal, it is the force that the surface exert on an object. So makungekho nje surface kusho ukuthi ne normal ayikho. Then sine tension, there is no normal ngoba I surface ayikho. So sine tension going upward, right? Akho friction ngoba kuzotiwa ignore the air friction. So njengoba sikhuluma nge air friction kusho akho friction. Angisiyakhumbula ukuthi masothi normal ayikho, and siyazi ukuthi friction ucalculate as a coefficient of friction times normal. Kusho ukuthi i-normal ma ingekho ne friction ayikho asikhulumi ngayo, unless ukuthi sokhuluma ngani nge air friction. Akusiyona le friction esikhuluma ngayo that is relative to the surface. So makuthi i-normal ayikho kusho ukuthi ne friction ayikho. So same thing esoyibuka ngalana, right? Mase siza kulo 16 kg. Kulo 16 kg nakhona sibona ukuthi khona gravitational force, mase kuba ne tension nayo ishona phezulu. Now sidinga ukwenza bani i-free body diagram noma ukudweba nokubhala i-net force, expression of the net force. Lana ayikho force so isusa ngoba this motion is vertical. This force is vertical, nalo vertical, nalo vertical, nalo vertical. Now i-issue lana, it is the issue of i-direction. What do we take as i-direction? Lokhu ngakudida ngoba ubona ukuthi i-tension iyaphezulu nale tension iyaphezulu, kusho ukuthi they all have the same direction, kanti akunjalo. Noma uzomothi u-FG lo ushona phansi nalo ushona phansi, when kumele ubhale i-expression of the net force uzoba ne-tendency yokuthi you separate these two motion. Lama block awu-2 are connected with the string, kusho ukuthi kune motion ehambisa konke kanye kanye, right? So emotion njengoba kushintsha direction, siyabona ukuthi lo 10 kg uya phezulu kanti lo 16 kg ushona phansi. So that is the motion we have. Leya motion enjalo sothini soyibiza nge clockwise, right? Emotion ekunika ukuthi uya phezulu then uya phansi, that is clockwise, right? So into sibuka as a direction, so khuluma ngani nge clockwise direction, right? So in that case sithe direction so ithatha ibe positive will be the clockwise ngoba yona direction of motion. So in that case ngizothini, tension uzoba positive ngoba upward on the left side, mase gravity ube negative because it's opposing the motion, right? Izoba negative. Mangiza kulo 16 kg block, yabothi gravitational ihambisana nani ne motion, kusho ukuthi gravitational force uzoba positive then i-tension ibe negative. So yabona ngala ukuthi u-negative la u-positive, even though ngesikhathi udweba i-free body diagram i-tension ikhomba phezulu nale tension ikhomba phezulu, but the two they do not have what, the same direction relative to the motion of the object. System move clockwise, right? So wenza njalo ke then wenze ama substitution yakwazi ucalculate tension noma uzocalculate ini acceleration, right? Again uyakhumbula ukuthi F net is equal to ma, nala F net is equal to ma, right? So that is a few things kumele ukhumbule about in Newton's laws, right? The next thing is it is about the other topics asele vertical projectile motion sakhuluma ngayo, mhlambe singathi kancane kwi momentum. I-momentum inama sections awu-2 awu-3. Yokuqala ikhuluma nge-momentum, ATP is equal to m times v. This says ukuthi momentum is the product of the mass and velocity. So kumele ukhumbule ukusebenzisa lama formula ukukhumbuza ama definition makuthiwa define i-momentum. So unikezwa i-formula uthi P is equal to m times v. When I just say this in word, P represent a momentum, equal load, m is the mass, v is the velocity. So kwenziwani between m and v, there is a product. So the momentum is the product of the mass and the velocity. Kumele ukhumbule ukuthi i-momentum is a vector quantity. Mangithi a vector quantity kusho ukuthi in a direction and in a magnitude. Most of the time uyabona ukuthi momentum isuka kwi-mass. Mass is a scalar and velocity is a vector. Ingakho this one is also a vector, right? So the vector nature ye momentum isuka kepi kwi-velocity, right? So lana sikhuluma nge one object. So the momentum of the object can change. Kusho ukuthi speed say object ingashintsha, makushintsha nje speed kusho ukuthi ne momentum izoshintsha. So the next thing to talk about will be the change in momentum. Change in momentum. So delta P. The change in momentum is simply the mass remains the same, so Vf minus Vi. The final momentum minus the initial momentum. You're still talking about one object. Then uzofaka indaba yani impulse. Indaba impulse now you're still using what? One object. Impulse is the product of the net force and the time, right? Then sobona ukuthi khona masi sebenzisa Newton's second law in terms of momentum. The net force is equal to the rate of change of momentum, right? Rate of change. Ungakhohlwa ukuthi rate of change of momentum. So ngibona ukuthi mangi manipulate le formula lo F net lo delta T uzozangala, so uzongikhiphela bani F net times delta T is equal to change in momentum. Kanti ngiyakhumbula ukuthi the product between the net force and the time kunika bani impulse. Kusho ukuthi ngizothi impulse is equal to the change in momentum. Right, so makuthi ngiyazi ukuthi I change in momentum ngiyakwazi ukuyithola, kusho ukuthi ngiyazi futhi value kabani impulse. Now uzobona ukuthi ku statement bese kuthiwa calculate the impulse. Kodwa when uyazi ukuthi impulse kumele uthole ube nani the net force nesikhathi. Mawubuka nje ku statement akukho nje into ehambisana ne force noma into ekhuluma ngesikhathi. But bakunika ini mhlambe ama velocity kuthiwa it's moving mhlambe at 2 meters per second, then the velocity changes to 5 meters per second. So bakunika ama velocity ashintsha. Then with those velocity into yazi ukuthi ungayithola I change in momentum. By the time uthola I change in momentum, I value change in momentum iyalingana nani ne value ka impulse. So impulse yona I unit yakhe ithi Newton second, angithi force is Newton and the time is in second. So in Newton second. Kanti I momentum yona siyazi ukuthi it is in kilogram meters per second. Angithi the mass is in kilogram and the velocity is in meters per second. Kusuka lapho ke as a unit. Right? So that's it. Then the next thing uyibukayo it's when now you have to look at two objects. When you have two objects, then sokhuluma ngani nge conservation of linear momentum. Conservation of linear momentum. Right? Lana sikhuluma ngendaba yani yama collision. Conservation of linear momentum. Lana kutiwa in an isolated system, the total linear momentum is conserved. Once the total linear momentum is conserved, kusho ukuthi I momentum object yokuqala plus I momentum of the second object or before, so ti ama initial momentum kuyalingana nani before kuyalingana after I collision. So I momentum the first object final plus the momentum of the second object. So you have that one, right? Akhumbula ukwenza lokho ngoba le formula ayikho kwi data sheet, right? So noma uzothi the sum of momentum before is equal to the sum of momentum after. Right? So we apply in conservation of linear momentum. Manje ke uyazi ukuthi makune collision sinama scenario awu 3 ekumele uwakhumbule ukuthi kungenza ukuthi ama object ahlukene then ayashayisana emva kwalokho ayahlukana ke futhi. So that is collision, then there is a separation. Ngoba le formula lens siyakwazi ku unpack ngoba siyazi ukuthi I momentum I calculate as the mass and the velocity. Right, that one we know it. Mass times velocity. So initial velocity. Then the second one is the mass. So the first mass, the second mass times initial velocity yakon. So this formula is nigga I momentum, the initial momentum, nalo siniga initial momentum. Subiyangala siphinde the same kodwa ngemanje sisebenzisa bani final velocity nala soti m2 times to final velocity, right? So yabona ke ukuthi the first object in a momentum yake nale in a momentum yake akho into efanayo, right? So uyakwazi ucalculator I momentum, total momentum on the left side, uyakwazi futhi ucalculate total momentum on the right side. The second option is when they collide, they move together as a unit. So still uzoti m1 v1 initial plus m2 v2 initial is equal to njengoba they move together as a unit, right? Kumele ukhumbule ukuthi I velocity izoba iyalingana ngoba they move as a unit. I scenario kuzothiwa hlambe there is a box, then there is a bullet, this bullet enzenjani, it stacks in the box. They both move together as a unit, so the speed will be the same. So ngoba nje speed siyafana, so sombiza bani uVF, then sibe no mass 1 plus mass 2, right? So that's it. The third one is when they are moving together, that can be called also in explosion, right? When someone has an object and throws the object away from him or her, then uzohamba in opposite direction. So kusho ukuthi initially velocity yafana, so uzothi uvi m1 plus m2, senza kanje ngoba initial velocity yalingana for both. Then ngala kuyahlukana ke, so you have m1 plus m1 final, m2 plus v2 final, right? So those are the two possibilities. Then yokugcina masukhuluma ngama collision, khumbula ukuthi khona elastic collision and inelastic collision. Elastic collision, it's when both total momentum and total kinetic energy are conserved, while inelastic, only the total momentum is conserved but the total kinetic energy is not conserved. Makuthiwa prove wena sebenzisa iformula ye kinetic energy ethi half mv squared, right? So njengoba kunama object awu2, then kusho ukuthi kinetic energy of the first object plus kinetic energy of the second object ungathi is equal, ngoba mawuthi equal kusho ukuthi wena usuyayenza as i-law or statement, uyasebenza nje ukwenze nje separately, ucalculate what is the velocity, I mean the kinetic energy of the first object, the kinetic energy of the second object, uthole inamba la, mase uyacalculate ke ukuthi after uphinde wenze the same thing, the kinetic energy of the first object, the final one, and the kinetic energy of the second, uzothole nayo inamba, mase ucompareisha lezi inamba, musho ukuthi equal, because by the time uthi equal phela wena suya conclude ukuthi kuyalingana. Ngoba igcineni into ehlekisayo ubona umfundi avela athi u200 is equal to 30, yabo, ngoba utheni uthe equal before you even do the calculations. So yabona ukuthi it doesn't make sense. So uthole inamba ngala uphinde uthole nenamba ngala mase uya compareisha. Mawukuthi lezi inamba ziyalingana kusho ukuthi le collision is elastic. Mawukuthi akulingani, that collision is inelastic, right? Avoid futhi kusho it's not elastic, uzothi is inelastic, right? So yeah, lokhu ke, and then we say ukuthi say ready ku exam, and we wish you all the best, right? Siyabonga grade 12.
Ningakhohlwa ukuthi nisengathokozela ezinye izifundo eziyisithupha kanye nezengeziwe i-learner wellness, i-career guidance kanye ne-advanced program. Hlanganyela nathi kwizifundo ezi-online ku-068 151 1072 noma ku-GoDigi@godigitalsa.today. Siyabonga.